All right, so we're going to expand form. So x to the power 3 simply means that we're going to multiply x how many times? 3 times, because my exponent is 3. On the next one, we have what's being multiplied 5 times. This inside the parentheses is being multiplied 5 times. So you need to make sure that you're multiplying all parts 5 times because they are in parentheses. This question is different than the one above because if you notice, it's not in parentheses. So what part is being raised to the power of 6? Well, actually, it's just the x is being raised to the power of 6. Nothing is being raised to the power of 3 because how many times do we have 3 being multiplied? Well, we only have 1 3, which means the power, if there's no power showing, it's the power of 1. Oh, let's go sneeze, sorry. So that would be 3 times, and then you have, oh, sorry, I feel like I keep sneezing. X, a total of 6 times. So again, I wanted to point out, if 3 does not have an exponent, you need to know that there's one of them, or the exponent is 1, which is why we only have that listed once. Okay. Next one is negative powers. Just a couple things to remind you, or shortcuts, is if they're in parentheses, that means you're multiplying all of it 4 times. If the exponent is a positive number and you're multiplying that 4 times, and not positive, if it's an even number, your answer will be a positive. So negative 5 times negative 5 is 25. This is also 25, and 25 times 25 is 625. So do you notice how that's a positive answer? Versus if you have an odd number exponent, well, negative 3 times negative 3 is 9, and then times negative 3, that you have negative 27. So it'll be negative answer. So if your exponent is odd, it's negative. If your exponent is even, it's positive. And that's just if you're multiplying negative numbers, just a shortcut. Okay. Another thing we want to point out that is important to know is that, again, if it's in parentheses, that means you were taking that entire term and you are multiplying it the number based off of the exponent. So in this case, it would be 4. Negative 1 times negative 1 times negative 1 times negative 1. Remember, that's an even. So I know my answer will be a positive 1. Versus this question here, again, what is being raised to the power of 4? It's actually just the 1 that's being raised to the power of 4, not the entire thing. So the negative kind of just hangs out there. And you multiply 1 4 times. So your answer will actually be a negative 1 because that negative never got multiplied by anything else. Okay, these are parts of what we're going to use when we're discussing things. So this is called our coefficient. This is our index, and this is our radical sign. And inside the radical sign is your radicand. Okay, the couple things that are important is your index tells you how many times you need that number to appear inside in order to pull it to the outside values. So we're going to talk about that. And the other thing we're going to talk about is what happens if we have a coefficient already there. So we're going to do some practice problems on that. Okay, so we're going to start off with prime factoring 90. So most of you would do 9 and 10. Neither of those are prime, so we're going to need to continue. That would be 3 and 3, both of which are prime numbers, so we circle them. I'm going to prime factor 10, which is 2 and 5. Those are also prime numbers. Now, if there's no number on the radical or in the radicand, if there's no number, it's automatically a 2 because we called a square root, square meaning 2. So we need 2 in order to pull it out of this radicand. So we look here, we have all these numbers here that have been factored out. Are there any pairs? Well, yes, there's a pair of 3s, which means we could pull that out of the radicand. What do we have left over? Well, we have a 2 and a 5. So instead of writing 2 times 5, we simply want to write our answer as 3 radical 10. That will be our answer. And then we're going to do 64. Now, you might know 8 times 8 is 64. Now, 8 and 8 are not prime, but remember, we only need to have pairs in order to pull it out of the radicand. Well, if we already know 8 are pairs, we can pull them out right away, and we'd only have an 8. There's nothing left over, so my answer is 8. That's no different than if I forgot that 8 times 8 is 64. And if I factor those out, I just want to show you that they are still the same answer. So 4 factors. So now I've already pulled out all of my primes. So I can pull out pairs. So here's a pair, here's a pair, and here's a pair. There's nothing left inside the radical. So what's 2 times 2? Well, that's 4. What's 4 times 2? Well, that's 8. Oh, isn't that what we had earlier as our answer? Well, yes, it is. So that's one option. Okay, let's go ahead and try this one. So we have, as you notice, we have a number on the outside that's called our coefficient. We're going to deal with that at the very end. So we're going to first factor out 20. So 4 times 5, 5's prime. 4 is 2 and 2. Now, what pairs do I have? I have a pair of 2's. So I can pull the pair of 2's out, and I bring it out. And remember earlier I said we're going to talk about what happens if I have a coefficient on the outside. Well, now I know that I have 2 and 5, so what is 2 times 5? 10. Do I have anything left over inside of the radical sign? Yes, I still have a 5 there, right? So that means it did not get pulled out of anything, so it stays inside the radicand. So that is my simplified answer. Square root of 20, we're going to factor that out. Oops, not a 5, sorry. So 5 is prime. 4 goes to 2 and 2. It is a square root, so we need pairs. We have a pair of 2's. That means I pull that out. What's left inside is just the 5. So my answer is 2 square root of 5, because 5 has to stay inside the radicand because it did not have a pair. Okay, let's do 48. Feel free to pause these, work them out, and see if you get them right. That's probably the best method. So 6 times 8 is 48, neither of which are prime. 3 times 2, those are both prime. That'd be 2 and 4, and that's 2 and 2. So we're looking for pairs because this is a square root. So we have a pair of 2's, another pair of 2's, and what do we have left over? We have a 3 that's left over. And if you recall earlier, what do we have with the coefficients on the outside? We multiply them. What's 2 times 2? 4, and we have the square root of 3 left inside. There's our answer. Okay, next one, square root of 125. Try to pause it and come back. Okay, square root of 125, we have 5, and that will give me 25. 5 is prime. 25 is 5 and 5. It's a square root, so we need pairs to pull it out of this radicand. So we pull the 5 out. Do we have anything left inside the square root? Yes, we have that 5 still left inside. So the answer is 5 square root of 5. Now, one of my students thought that you would have, or one of the questions was, why isn't 25 outside? Well, remember you're pulling out the square root, because 5 times 5 is square root of 25, right? You wouldn't say the square root of 25 is 25. No, because you have factored out 5 and 5. So the square root of 25 is 5. So I just wanted to point that out because one of my students had asked. There's two different ways of doing this. First, you can see, does 49 divided by 81 evenly? If it does, you can do the square root of that. If it doesn't, which in this case it doesn't, I might notice that square root of 49 is a perfect square. I may also notice the square root of 81 is also a perfect square. Well, what's the square root of 49? 7, because 7 times 7 is 49. What's the square root of 81? 9, because 9 times 9 is 81. Okay, let's try some variables. So x to the power of 10, if I wrote that out, that would be x times 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 x. So in order to pull it out of a square root, you need pairs. How many pairs do I have? Well, there's one pair. There's another pair. Another pair. Another pair. And another pair. And when we pull out all of these pairs on the outside of the square root, what do we do? Do we add them or do we multiply them? Well, think about the other ones. What were we doing when we had coefficients? We had to multiply them. So what do we have on the outside? We have x to the power of 5. Do we have anything left inside? No, we have used all of our x's. So x to the power of 5 is our answer. A shortcut to that is just saying how many pairs do we have if we think of them shoes. If I had 10 shoes, how many pairs of shoes do I have? 5 pairs of shoes. Okay, so that's a shortcut. So let's try the shortcut on this one. How many pairs of shoes? If you have 7 individual shoes, how many of them are pairs? Well, 3 of them are pairs. Do you have any singles that are left over? Well, yes, you'd have one pair that's by itself that doesn't have a pair, one single shoe. So that would be your answer. If I wanted to show you written out in expanded form, okay, here's a pair, here's a pair, here's a pair, and then, oops, and then I had one that was left over. So remember, we multiply them on the outside if it's a coefficient and leave it alone. So they're the same answer. So if you can think of them in pairs, it takes less time than writing it in the expanded form. Okay, let's try the next one. Again, feel free to pause, practice it, and then work it through. Okay, so 324, you might know that's a perfect square, and if you do, that saves you a lot of time. If you don't, let's say, okay, well, that's a big number. I don't know. Okay, well, let's say you only went with 2. So that would be good. 2 goes into 3 once. That goes in 6 and 2. 162. Well, that's even. Oops, forgot to circle that. So that's 8, and that's 1. 81 is 9 and 9. Oh, good. I already know 9 and 9 are perfect squares. So I'm going to pull that as my pair. So I need pairs because it's a square root. So I have a pair of 2s. I have a pair of 9s. Okay, and then I have x to the power of 6. I'm still going to do that in a minute. So what do we do with 2 and 9? Well, hopefully remember you multiply them. The next question is, how many pairs do I have out of 6 shoes? I have 3 pairs. Do I have anything left over? No. So that's my answer. Okay, let's try the next one. 96, you might know it's 14 and 14. If you didn't know, let's say you're like not good with your perfect squares yet. So let's use 2 because it's an even number. So that 2 goes into 19, 18 times. 1 left over, so that's 16, so that's 8. 98, let's say I don't know again, that's prime. So let's use 2 because it's an even number. So that's 4. And then bring that, that's 9. Oh, 49. I do know that one's 7 and 7. So let's go ahead and use those 2 as perfect prime. So I'm going to pull out my pairs. I have a pair of 2s. I have a pair of 7s. Remember, I'm multiplying what I pulled out of the square root, and then we'll do the variables secondly. So what is 2 times 7? Well, that is 14. How many pairs of M's do I have? So if there's 8 shoes, how many of them are pairs? Or you could think divided by 2. So there's 4. And then N's. How many pairs of shoes would I have if there's 7 individual shoes? Or divided by 2. You would have 3 pairs. Do you have any left over? Yes, you'd have 1 left over. Okay. Go ahead and factor out. Pause and try to do these ones by yourself. Okay, so square root of 8 is 2 times 4. 4 is 2 times 2. Okay, we're going to pull out our pairs. So we have 1 pair. So we're going to pull that 2 out. But if you remember, I have a coefficient already there. So we're going to multiply those 2 numbers. And we still have in here a 2, x to the power of 9. So we're going to do our variables next. So 2 times 3 is 6. We have the 2 there. And then we're going to do our exponent. How many pairs, or divide that by 2. So that'll be 4 pairs. And we have 1 left over. Again, if you don't